Hello everyone, welcome back to my channel. So today in this video we are going to discuss past year paper from October-November 2020, and this paper is pure mathematics 3, that is 9709, and component is 31. So here we will be discussing few questions in this video and rest of them in the next video. So let's begin. So here's the question number 1. Solve the inequality 2 minus 5x is greater than 2 times modulus x minus 3. So we have seen whenever we have one side modulus, the best way to solve these inequalities is to sketch the diagram. Once we'll sketch the diagram, we can see the scenario what we need to find. So I will draw it with the help of software. We need to draw it manually, by the way. So here it is drawn, and this line red curve is y is equal to 2 times modulus x minus 3, and this black line is y is equal to 2 minus 5x. So we can see, because we require the point where we require the inequality for which this black line is greater than the another one. So this is the only place where we can see that black line is bigger above the red line one. So we require this point, because everywhere else we can see the black one is below the red, means black 2 minus 5x is always less than 2 times modulus x minus 3 apart from this point. So we require this point, and this inequality will be x is going to be less than this value. So we can see now, because it's a reflection of this modulus one, so this line would be y is equal to minus 2 times x minus 3. So we are going to find the intersection of this line and y is equal to 2 minus 5x. So it is 2 minus 5x greater than minus 2 times x minus 3. So it is 2 minus 5x greater than minus 2x plus 6, or 2 minus 6 is greater than 5x minus 2x, or we can write x 3x greater than less than minus 4, or minus 4 over 3 is greater than x. So we will write it in this way, that is why x should be less than minus 4 over 3, and we can see it is here, and this point is more than less than minus 1 and more than minus 2. So this is the solution for this inequality. I hope it is clear. Let's do the second question. Here's the second question. On a sketch of an Argand diagram, shade the region whose point represent complex numbers z, satisfying the inequality modulus z is greater than 2 and modulus z minus 1 plus iota is less than or equal to 1. So we can see in both the cases it is these are the circle. So this represents it, we can write it as z minus 0 greater than or equal to 2. So it is a circle, and we will shade the area which is more than 2, so which is the outer part of the circle. And for this one it can be written as z minus 1 minus iota is less than or equal to 1. So in this case the center is, here the center was origin, and here the center is 1 comma minus 1. So this would be this is less than or equal to 1, so we will shade the inner part of the circle, and intersection of those will be denoting the required region. So I will draw it on PowerPoint and I'll paste it here. So here is the diagram. We can see the z minus modulus z is greater than 2. So for that the origin is the center 0 comma 0, and the radius is 2. We can see if this is 1, so it is 2 here accordingly, and the radius of this center of the smaller circle would be 1, because it is 1 comma minus 1. So this point complex number is 1 minus iota, and this radius is 1. So if we'll shade both the inequalities, we can see The first inequality is above, means outside of the circle, and the second inequality is inside of the circle, so the required portion is this shaded region. I hope it is clear. Let's do the next question. Here's the third question. The parametric equations of a curve are x is equal to 3 minus cos 2 theta, y is equal to 2 theta plus sin 2 theta. For theta between 0 and pi by 2, we need to show that dy over dx is cot theta. So we know dy over dx we can write by chain rule as dy over d theta into d theta over dx, and we will calculate dx over d theta and dy over d theta from the given parametric equation. So dx over d theta means we are going to differentiate this with respect to theta, so it is 0 minus cos 2 theta, it is going to be minus sin 2 theta, and then again the differentiation of 2 theta is 2, so multiplied by 2. Altogether it becomes plus 2 sin 2 theta, and here dy over d theta, dy over d theta is equal to differentiating this with respect to theta, we will write it as 2 plus sin 2 theta, differentiation is cos 2 theta, and differentiation of 2 theta is 2, so I'll write 2 here. So now we have dx over d theta and dy over d theta, so we can calculate dy over dx, and it is going to be 2, I'll take common, 1 plus cos 2 theta over, it is d theta over dx, so divide by dx over d theta, so this become 2 times of sin 2 theta. These two got cancelled, and we'll use the double angle formula for cos 2 theta, that is 2 cos square theta minus 1, so it will become 1 plus 2 cos square theta minus 1 upon, and double angle for sine is 2 sin theta cos theta. Now these two got cancelled, and we are left with 2 cos square theta over 2 sin theta cos theta, which will be cancelled, and cos is also cancelled, and we are left with cos theta over sin theta, and this is cot theta, and hence proved. This is what we need to show. Now let's do the next question. Here's the fourth question. Solve the equation log base 10 2x plus 1 and 2 times log x plus 1 base 10 minus 1, and give your answer correct to 3 decimal places. So give your answers, it means we are going to get more than one answer, more than one value of x. So we are going to solve it, and here we can see this is log, but it is not log, and we know that log a base a is always 1 for any base any value a. So we can write 1 as log 10 base 10, so that everywhere we will get log 10. So this equation can be written as log 2x plus 1 base 10 is equal to log x plus 1 whole square, because it's in the multiplication, so it will go in the power base 10, and 1 I will write it as log 10 base 10. So we will use the log property, and one more times we'll write it 2x plus 1 base 10 is equal to log x plus 1 whole square divided by 10 and base 10 here. Now we can remove the log, and we'll get 2x plus 1 is equal to x plus 1 whole square divided by 10, which can be written as x square plus 2x plus 1 x plus 1 whole square identity, and over 10, which can be written as 20x plus 10 is equal to x square plus 2x plus 1, which we can write as a quadratic in x as x square 2 minus 20, so minus 18x, plus 1 minus 10 is minus 9 is equal to 0. Now we will use the quadratic formula to get the value of x here, values of x. So x become minus b, so 18, plus minus square root of b square minus 4ac, that is 324 minus minus plus 4 9 are 36 over 2a, that is 2. We'll solve with the help of calculator, and this value we will get it as 18 plus minus 6 root 10 over 2. It is 6, not decimal, or we can write it as 9 plus minus 3 root 10. So now from here we will calculate the two values of x till 3 decimal places, because they require it till 3 decimal places. One is 9 plus 3 root 10, which is, let me calculate it, 9 plus 3 root 10, this value is 18.4868, so 487, and another value is x is equal to 9 minus 3 root 10, which is minus 0.4868, so 487. So these are the two values for x for this equation. So I hope it is clear. Let's do the next question. Here's the fifth question, A part. By sketching a suitable pair of graphs, show that the equation cosec x is equal to 1 plus e raised to the power minus half x has exactly two roots in the interval 0 to pi. So when we'll draw the two graphs, so we can draw the two graph as y is equal to cosec x and y is equal to 1 plus e raised to the power minus 1 by 2x. So if we can get two point of intersection, then we can say that there are exactly two roots. So let's say it is coordinate axis, and it is 0 degree, and let me see, it is pi by 2 somewhere here and pi somewhere here. This value, let's say it is 1, and this value, let's say it is 2. Similarly, it is minus pi by 2 here and minus pi. And it is not required to draw it here, just to draw and see the symmetry of y is equal to cosec x. I draw this. So y is equal to sin x go like that. In the same way, y is equal to cosec x will be a graph of this type, where this is going to have a point value of pi by 2 as 1, and then it will go back till infinity. Now this is y is equal to cosec x. Similarly, we know that y is equal to e raised to the power x is this graph. This is y is equal to e raised to the power x. So y would be, this is the graph of y is equal to minus x, and since it is 1 by 2, so it would be stretched along this axis, and there is a plus 1, so plus 1 means this graph will go up. Earlier the graph was supposed to go like that, This is the graph of y is equal to e raised to the power minus 1 by 2x. Now if it is plus 1, so this graph will go from this place, 1 will become 2, and then it will intersect at 2 point, and this graph will be like that. So this is the graph of y is equal to 1 plus e raised to the power minus 1 by 2x, and we can see it intersect at 2 points. We can write, since the graph intersects at a and b, let's say they intersect at a and b, hence there are exactly two roots, in 0 to pi. So this is how we'll do this. I hope it is clear. And let's do the B part. The sequence of values given by the iterative formula this xn plus 1 is equal to pi minus sine inverse 1 over e raised to the power minus half xn plus 1 with initial value x1 as 2 converges to one of these roots. Use the formula to determine this root correct to 2 decimal places. Give the result of each iteration to 4 decimal places. So it is a iterative formula and it is given that it is going to converge. So we are going to use the calculator and find the different value. We have x1 as 2, so we can calculate x2 as pi minus sine inverse of 1 over e raised to the power 1 by 2 times x1, and x1 is 2 here plus 1, and we will be calculating it from the calculator directly for the each step. We'll first of all store the value of answer as 2 as the initial value, and then we'll write the whole thing in the calculator so that next time we don't have to write the value again and again. So it is sine inverse 1 over, this value is 2.3217. we need to write till 4 decimal place, so it is still here. And then the next value, that is x3, we are going to simply press the equality button and we will get the next value, and the value is 2.27598. so it is, we can write as 9 and so on. And the next value is going to be x4, 2.28240 and so on. Next value would be x5, 2.28150 and so on. Next value we can write one more time, x6 as 2.2816 and so on. So we can see the till 2 decimal place we are getting 282828 everywhere. So the value of this, the root, one of the root is going to be x as 2.28 correct to 2 decimal places. So that is the answer. I hope it is clear. Here's the sixth question, A part. Express root 6 cos theta plus 3 sin theta in the form of r cos theta minus alpha, where r is greater than 0 and alpha is in between 0 and 90 degree. State the exact value of r and give alpha correct to 2 decimal places. So we will write it in this form, and we know r cos theta minus alpha is r cos theta cos alpha minus plus r sin theta sin alpha. So we can write directly, let's take it as root 6 as r cos alpha, and not root here, 3 as r sin alpha, so that it will make a formula identity of this form, because cos theta minus a minus b is cos a cos b plus sin a sin b. So we have taken the first number here as cos alpha and here as sin alpha. So from here, if we'll square them and add them, we will get it as r squares, and sin square plus sin square alpha plus cos square alpha is 1, so it is only this. So from here we got r as 9615, so it is root 15, that is the r in the exact value, and this is the exact value they have asked. And the next one is, if we'll divide the first part from the second one, we'll get r sin alpha over r cos alpha as 3 over root 6, and this will give tan alpha as 3 by root 6, and hence we can calculate alpha by taking tangent inverse of this value, and we can calculate, and this value is going to be from calculator 50.768, so 50.77, because they have asked till 2 decimal places. So we have alpha and we have r. So in this form we can write this value as, one more time, r cos theta plus 3 sin theta as root 15 cos theta minus 50.77. So whenever we have anything of this form, we can write in this way as well. Let's do the second part of this question. Here's the B part. Hence solve the equation this. We have in the previous part as this as theta and this as theta. So we have written this left hand side as root 15 cos of theta minus alpha, and where alpha was 50.77. so here this is same as this, we can write it as root 15 cos of theta. In place of theta it is 1 by 3x minus 50.77. These are the equivalent form of it, and hence we need to solve this is equal to 2.5. Before this we will see the x was in between. If x is in between 0 to 360, it means x by 3, because we have this as the new angle. So 1 by 3 x would be between 0 to 1 by 3 x between, and 360 by 3 is 120. 3 by x by 3 would be in between this, and hence 1 by 3 x minus 50.77 will lie between minus 50.77 and 120 minus 50.77, that is 69.23. So this will give us the idea till what point we are going to find the angle, different angles. So from the equation we can write cos of 1 by 3x minus 50.77 is equal to 2.5 over root 15, and hence from here 1 by 3, that is the angle 1 by 3x minus 50.77 is equal to cos inverse of this value, and cos inverse of 2.5 over root 15 is 49.797. so I will write till 3 decimal place first. So now we will see if we have to find any other angle as well, because it is till between 0 minus 50.77 and 69.23, and for the different angle for cos, the next value for the cos, we know that the different angles for same value we can take minus theta 360 minus theta 360 plus theta. These are the different angles. So one angle is 49.797. if you use this or this, we will get the angle which is going to be more than 69.23. so the next angle we can think of is going to be minus of the angle. So the new angle, another angle for this is going to be 1 over 3x 50.77 as minus 49.797. so that's it, and let's find the value of x. So from here if we'll solve, we will get 1 by 3x is equal to 49.797 plus 50.77, and this value would be 100.567. and similarly from here 1 by 3 of x would be, let me add, this is going to be minus 49.797 plus 50.77. this value is going to be 0.973. so these two values would be x is equal to, if we multiply by 3 we will get the exact value of x, and this is going to be 2.919. so till 3 significant figure, if you want to give the answer, then we can write 2.92, or we can write 2.9 only, because generally we give our answer till 1 decimal place if it is the angle. so 2.9 degree here, from here, and from this place it is going to be 3 into 100.567, and this value is going to be 301.701, so it is 301.7 degree. so these are the two values of theta, which is in between 0 and 360. so that's it. I hope it was of some help. We will discuss the last 7th, 8th, 9th, 10th and 11th question in the next video. Till then, thank you so much.